Hello and welcome to our What's New in 12D webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. While we wait for everyone to finish joining and get comfortable, I'll be launching 2 polling questions. You'll have about 30 seconds to answer each and then I'll show the results. Firstly, we'd like to know, did you attend any of the previous parts of this webinar series this week? Both parts 1 and 2? Part 1 only? Part 2 only? Or none? Okay, it looks like most people have been to the previous sessions, but we do have some newcomers, so welcome. Next, we'd like to know, how many people are watching this webinar with you? Is it just you? Are you in a small group, or are there more than 5 of you in the room? Most people are here by themselves, but we do have some groups, so welcome everybody. 12D Solutions will be releasing the new 12D Model 12 in September 2016, and this webinar series has been highlighting some of the new features. These presentations are designed to give 12D Model users an insight into the new features and enhancements in 12D Model 12. We'll also be discussing some of the new features in 12D Synergy 3. Both new product releases will be showcased in more detail at our upcoming 12D International Conference in July, but these webinars will provide an exciting preview of things to come. Our main presenter today will be Dr. Lee Gregory, the Managing Director and Co-founder of 12D Solutions. We'll also hear from Peter Tainton and Paul Hardwick of 12D Queensland, Rob Graham, our Resident Water Resources Engineer, and 12D Synergy Technical Lead Richard Stollier. For now, over to you, Lee.
Thank you, Lisa. Welcome everybody again, especially those over in the West. Today, you know the drill, we'll be going through things in 12D Model version 12 and Synergy 3. And for all those who come to the conference in July, they'll get a technical preview version of 12D Model, as long as they're on maintenance, so they can look at things before the release in September. And it just lets you know again that the Innovation Awards, you can win part of those $15,000. It can be a small entry, might just be half a page, if it ends at the end of this month, so get your entries in as soon as you can. Right, I'm just going to answer some of the questions we've been getting first off, so everyone can hear what they were. There's a couple about subscription licenses and other things. I'm not certain why it's such a hot topic at the moment, but what I had to do first, though, is need to know a little bit more, and that was some were asking about Perpetual, some subscription. So what first is a Perpetual license for 12D Model? That's where, and all of you beyond Perpetual, or most of you now, you pay a once-off Perpetual license fee, and then there's an annual maintenance fee charge of 15%, and for that you get full support, discounts on additional licenses and free upgrades of that are released whilst you're on maintenance. If you don't pay for your maintenance, you can still use your current version of 12D Model. Subscription, that's actually where you pay either by the month, quarterly, or annually, or triannually, and basically when you stop paying the money, you don't have access to the software, so you can't access any of your data, you're locked out. It's also known as rental, and that's what we call it since 1991, so we've had subscription and rental for about the last 25 years. The question seems to be, which are we going to offer? Well, yes, we're having perpetual licenses. They're going to continue for anybody. There's no problems there. And you can get subscriptions, no problems there. And if you want, you can get any combination of those. It's up to you. It's your choice. So, yeah, there's no change in our policy. You can have whatever you like, whatever fits in with your situation and your budget. Another question was, what happens to the crash logs that people send us? Well, we do try and track them as much as possible, but we've done a lot more work recently. We have found that with version 11, we've had a bit more instability than our previous versions, and a lot of it's to do with us trying to stop that Microsoft sending the darn screen white when you don't do something, and what we call keep the messages flowing. We think we've sorted out most of those problems with 12, but to make sure we catch these sorts of things, we have beefed up our crash log system, and our programmers now get daily reports of all the crash logs that come in, and our support people and resellers get monthly reports, showing them how many crashes a customer has had and who inside there had the crashes. So they can get onto you and chase up, try and find out what the problem could be. The other thing we're introducing in 12 is that we can produce a log of all the options you use in a session. It goes into an options used file, and that crash log can include that file with it. So it gives us a much better idea, because the crash logs often don't say very much, but we can see exactly what you were doing and the sequencing up to it. So keep sending us your crash logs. We do get them. We are monitoring them, so we know they all come in. And so all you have to do is send them to us whenever you get a crash. The other thing is super important, though, if you can repeat the crash and you've got data that you can repeat it with us, because the biggest problem is we often can't repeat them, can you please also send us later on the project, the 12DA data and the 12D XML, and then we can actually run it and find it on our machines when we can crash it in front of us. Will there be any What's New documentation? Yep, the same as in V11, there'll be What's New in version 12 PDF. It's about 100 pages at the moment and growing. Can you, one of the questions here is, can you set up a series of views automatically when you're creating a new project? And again, the question there is yes. In fact, you can actually do it now. There's a setups file in version 11, which you say what views you want. But in 12D, we can do a lot more. Because as we've seen with the view favorites, you're able to record all the information about a view, all the settings, that can be saved away, and you can actually run it from a chain. And a lot of people mightn't realise that when a new project starts up, we run a file, and any macros and chains in that file we run. There's another file which is done on an existing project. So you can set your thing, differentiate between the two. So you're using your favourites now, you can have your views come up exactly as you want them. Importing 3D solids. These are from AutoCAD into 12D, so you convert them to tri-meshes and cut them in sections, like say with the head wall we had. Well, the answer is sort of yes and no. DWG is a proprietary encrypted format, basically controlled by Autodesk, and so it's impossible to get the data out. We have to go work with another consortium to try and figure out what's in it. Seems to be something wrong with these. It's mainly US companies. They like to lock you in so you can't get at your own data and stop other software. And that's where the whole idea of really BIM came from, to have an open format that everyone knows, can read and write, so you don't get locked in like that into silos. So as long as you can get the data out into something like a polymesh, you might be able to write it out as a polymesh, then we'll be able to read it in and create tri-meshes. In our MTS snippet section, how are the different pavement layers created and assigned in the section view? Well, you don't actually have to do anything special on the section view. When you create tri-meshes, and it might be with snippets, could be standard MTF commands or any other commands, you've got your snippet, and if the snippet is closed, now that means it totally folds over and connects to itself. So you can think of it if it's like a bowl, if you can put water in it and it can't get out, then it's closed. And if you then section through that, it'll be shown as solid. If it's not closed, that means we call it open, then when you section through, it'll be shown in an outline. Can tri-meshes be plotted on cross-sections yet? Well, actually, I thought for most of the version 11, you'd be able to plot cross-sections, the straight line ones and that. So if there's any more you're asking or you're having problems, just give us a yell, just send us an email so our people can chase it up. Is it possible to model multiple electrical conduits? Now, I wasn't quite certain what meant by model here. Is it an electrical thing, or are we just talking about a 3D entity? If it's just 3D entities, yes, you can have as many pipes and that as you like. Will the water supply nodes we discussed yesterday be compatible with BIM and IFC so they can, are they attribute enabled? And yep, those nodes and the links as well for that are like drainage bits and drainage pipes. We can have as many user-defined attributes as you like, and we put results into those as well, into those attributes. So that means we can put them out to IFCs and BIM. And that's where the attribute manipulator is fantastic to get them in the right form that some of these other packages can take. Any chance of some house connection customizations or something along those lines? Well, it's been on our wish for a while, but I haven't seen it as yet. Could you please send us some information, though, on what you're actually after? So just how customised all these things have to be, to see what we might be able to do about it. Updating driveway volumes. If the area changes of the driveway, does the concrete volume update automatically? Now, I wasn't quite certain here because what you actually meant, if the driveway is done as a tri-mesh, then the volume is automatically calculated. If it's a closed tri-mesh, you get a volume. So if it's a polygon, well, yeah, you can find the area of a polygon at any time. So it just probably depends what you want there, but it should be fairly automatic. Can you export the custom added attributes to Navisworks via IFCs, for instance? Well, yes. As you can see, attributes can be written out to IFCs. I think you'll probably see another example today where Pete writes it out to Celebri of ADAC attributes. And so, again, the attribute manipulator allows you to get it in the right way so it can go out to these other packages. Will you be able to set the number of decimals for other things like volumes? Now, I presume this has come from where for the drainage people they could set the number of decimals to be shown on the calculation. So I wasn't quite certain where this is. But if any of our XML reports, we supplied the XSLT to produce the report, so you can go in and change the number of decimal places. But just let me know if you were thinking about it in another way, that I just have misinterpreted. Can you get accurate volumes from a tri-mesh yet? Again, I'm not certain there, because any closed tri-mesh, it gives you just do a inquire on it and it gives you its volume. So I'm not quite certain what you meant there. But you'll see, we saw the other day, there's other options for finding volume, say, when you're chopping down a tri-mesh. So, yeah, let me know again if there's something else you meant. This one I can't really answer. It says it's a bit unrelated, but can we expand the default measure toolbar dialog box to show another character, example 2 to 3 decimal places? Unfortunately, I wasn't quite certain what it does now. I know there's a display decision value in defaults, but I don't know if you change that if it show any more room. But again, I'll have to get someone to chase that one up. Right, so there's some of the questions we've been getting, and sort of come back to you with some of the answers. Now, off we go with some new things in version 12. The first thing is to do with helps. In version 12, we're actually going to be installing the 12D model reference manual and the programming language manual as PDFs. Before they were on the DVD, but a lot of people didn't realise that, so we will be copying them across. The good thing about a PDF is most people can view them easily, most people can print from them, and you can just look at bulk information, which with most other systems is very hard. So under Help 12D Macro Manual, even I yet to really always call it the Programming Language Manual, it'll come up and give you the PDF of the macro manual. With the Help 12D model, that will now come up with the full 12D model reference manual, again the PDF version. But what else is, there's this context sensitive help. Now people might realise what we mean when we say that, but basically this is when if you've got an F1 key, you use that over a menu or panel, or you press the help button, it gets you the information about that particular panel or menu. So it's sensitive to the context. So in 12D version 12, we've actually made it so your PDF of the 12D model reference manual can be used as your context sensitive help. So this can replace your Win help. So for a help button, so on a thing, if you push that on your panels, it will then come up now, it goes to its position in the PDF help. And for an F1 key, which you can do on any of the menus, the top of the menus, or again even on any panels without buttons, or even on ones that help buttons, or even ones that do have, you can still use F1 key, and that again will take you to that part of the PDF. So hopefully they'll save or fix up most people's problems with where they couldn't use the Win help. Now, we've had people asking about the user report for the network code meters, and a lot of people are starting to move across to the network code meters. You have to be on version 11 and above to do so, and we can actually report from 12D model the names and numbers of users on your CodeMeter network dongles. And this will be particularly useful when you've got 3 or 4 virtual dongles in the one dongle. So it's under Project Management, Dongles, CodeMeter Network Users, surprise, surprise. And actually, if you hit the report button on with no file, it actually will just come back with the total number of licenses on the network dongles, and all the virtuals, the number of them in use, and how many you've got left. If you fill in the report file box and choose the way you want to report it, in this case, our one we've got set up as an HTML report, and so this will now list all those people, the number of people there, which dongle they're on, the name of the dongles, and so on. Right, what we're going to look at now is ADAC. Now, ADAC has been used very widely in Queensland, and now it's starting to spread through the rest of Australia and into New Zealand. And it's actually very important. Basically, a group of local councils and water authorities met and they decided they would do three things. All use common 3D definitions of assets and metadata and attributes for these assets. So they're all going to do the same thing. So that's a very important thing, not do something different to each other. They're all going to have one XML data transfer format for these assets. So everyone wrote the same file and read the same file. It was totally defined. It was going to cover both as constructed and design of assets. So they looked at it quite carefully to get around all the problems they foresee with getting lots of data transferred. And the definitions of this XML, they made freely available to industry. So basically it was what I call open data. Now that is critical. Having this data transfer format and a freely available. Without that, just defining what the metadata and that, it's useless. It's like building a bridge halfway across a river. You get halfway, doesn't help you at all. It's just as useless, you might as well not even started. You've got to go the full hog. So once you've got a transfer format, everyone knows exactly how to read and write the data, so you're not locked into any proprietary things. So that's what they've done is fantastic. So what they've done, they provide the ADAC XML schema definition, which is called an XSD, so that says exactly what's in there, the general ADAC guidelines for the assets, and each authority who is asking for it then has their local versions to say what data in there they want and what they don't want. So basically with this one file format, anyone who can read it, they can all transfer data around. So the fact that we can read and write it for one place, everyone can use it. As far as BIM vendors out there, so you can see from all that, ADAC is a BIM system. It's actually controlled by the Institute of Public Works Engineers, Australasia. So you've got a group who's looking after it who looks after all of us. And they do have this vendor independent transfer format. It's supported by most of the major vendors, so obviously we support it. And you've FME, which is most councils and things have for reading and writing data, which means Esri, MapInfo, all those sorts of products automatically now can read and write ADAC data. So there's no big problem for a group to use it. So we have in version 11, we started at having ADAC available to people. And combined with our now attribute manipulator, it really makes it really easy to do. So you can bring design data or as-built data and go straight into the ADAC format. So what I'm going to do is show you how it actually works. Paul, our surveyor from Queensland, Peter, and Paul have been doing lots of training with people, just to give you a bit of an idea how it sort of works.
ADAC first made an appearance in version 11 and has, through the life of version 11 into V12, been upgraded, options have been upgraded and new ones added. Control D directly accesses the ADAC XSD file, and that way they're able to read in from the XSD file elements and create assets that are on the model. That then allows the user to edit the assets and understand what ADAC is all about. Once you define which assets that you require, you copy down, give them a name that suits your survey or your design, and create your own assets. From there, the idea is to create a mapping file. So look at some of the assets we've copied down. So here we've actually set some names and options for material and class that do reflect the name of the survey code that we are going to use. Here we've got the same name for all three of these manholes. So these ones here are going to be used in survey, and it's the surveyor's attribute called pit shape that will define which one of these and what sort of ADAC asset it's going to be. Once you've got your assets, you can then create your mapping file. So here we've introduced the use of a council requirement UAF file, and then information in there of what the council does and does not want, and then also a safeguard override that allows you to safeguard any change that you have done here. Then you write out your map file. Have a look at the council UAF file. We've got an example one here. Again, and there's the direct access to all the assets from the ADAC XSD file. Some of the options in there are nillable, means they're optional, so you can just quickly tick those off if the council doesn't require them. For the other ones that are not, we'll utilise the word required, NA -999 for real values that we require, and -333 for ones we don't. And the nose values are then utilising your mapping file and your validation. So as goes the overrides. In that case, we've got options we've set up that we don't want to override with the council requirement. We want to use that, so we can just set it to the label, WS for water supply, edge of bitumen. These are the assets that we wish to safeguard. Besides being able to utilise a map file and to convert your data that you do pick up in the field, there's also a global option you can do once you've actually got the data into 12D. So these are all under stormwater, sewer, transport, and so forth. So you can go to the pit and set all these attributes manually. It's quite quick, and it has the option to utilise the council file. In that case here, it then greys out all the things that the council doesn't require. So it's just another way of being able to set attributes for the transfer through to ADAC. During the transfer through to ADAC, 12D does do a lot of calculations and work for you. It'll calculate lengths of strings, grades of strings, inverts, covers, areas of things like road polygons, lots, and so forth. But there are a few things that the user will have to do, and we've got some tools to aid in that. So we've got a simple one, set pit numbers from text. In this case here, we've got some text that reflects the number. We just go around and go pick. So in case here, we're just picking the number, picking the text. Again, pick the manhole, pick the text. So it doesn't take too long, even in this process, to work your way around. Once you go accept, it sets the attribute ready for the connection with ADAC. How the connections are quite detailed inside ADAC. There's a lot of things you have to pick up and calculate. So this option allows you to pick them and does the calculation for you. So here I'm going to pick the line. It shows me the direction of the flow, so I know straight away where the downstream manhole is. I'll get a change option, so it gives me a dimension line from there to the asset. I'll get the IO distance from there to the end of the connection, the offset from the sewer line, the nearest boundary, and the next nearest boundary. Again, if you go to set, it will set all those attributes that are then mapped through to the ADAC attributes. And if you've already done one of these before, you can go pick, and it will then return the values here, so you can manually change them. If you go dim on these ones, it will show you the dimensions that you did use. On the toolbars that are available, we can go up under the setup for a survey project. It'll then create the views that we need, the data survey to map, and then the data ready for ADAC. So we've got some, use our favourites, add in our data. We have data plus a header file. The header file contains information about the project, horizontal and vertical. And so if we go to our chain and run local survey to ADAC, here's our ADAC ready data. There's a validation process there. We can write the ADAC file out and also even import the ADAC file for checking purposes. Inside here, we're going to just go report. We're reporting on the data to HTML. And then we've got information about the series manholes, series pipes, and so forth. In yesterday's presentation, we had a new label map file option, and we got one very similar for ADAC. Here we've got a ADAC label file. We'll read the file in. Same sort of idea. It has the same variety of label types, points, point leaders, polylines, and so forth. This labels only ADAC attributes, so obviously you have a link to the XSD file. It has the same option, decimal places, prefix, suffix, and the model to place those labels on. You can run the labels here. We'll just do a couple at a time. So we're going to pick our manhole. We're going to label. We're just going to do series, so you can just do the asset or the category that you're after. We can go right or create. So add in our labels. label manholes. Again, you can work your way around doing one at a time. Obviously, you would pick the whole model. So if I go and grab a pipe, add on the pipe model. If it uses a leader because it's the pipe's less than this minimum distance, and you can move these around. So we go down to a pipe that is long enough. It'll then put the text on the actual pipe itself, interlevel upstream, downstream, and information about the pipe. So again, if we go and label our connections, same process, add the model in. So again, under here, just like the label map file yesterday, you can edit leaders. It's a smart option, so we'll remember where that leader was. The same goes for text. So I decide to move the manhole. And if I go update, it remembers where that is. Here's a more detailed one, done exactly the same way. Viewing the ADAC data is useful in all sorts of ways, and one of the ways you can do is to send it across to Google Earth through the KML output. So to do that, though, the attributes that are on the ADAC, which are tree structured, need to be flat for KML, and that's uses the manipulator file, put ADAC to KML. Here it just simply takes the tree structured ADAC and puts it into a flat list KML. The file IO data output KML, you select your data, select the region that you're in, follow the Google Earth terrain, and then output. So you end up with information like this, so you can click on the manholes, lines, and it will return all the ADAC information for you. We haven't forgot about the actual design side of things. Again, there's toolbars there as well for the ADAC transfer in the design. In the design, the drainage network for stormwater and sewer will go across complete to ADAC automatically. The other design strings that you may use to go to ADAC, not all design strings go across ADAC, but you do have access to the usual name. But you now have, in version 12, the ability to set attributes. Here we've got a footpath string that we've set in our design, and we're going to then give it an attribute, ADAC attributes / path and the surface material. Again, we can then work our way down. These are all things that ADAC requires as a footpath, whether it's a shared footpath, what sort of material, the width of the footpath, and also the depth. We've also set it up for any water services. Now the information change of curve profile from barrier to rollover, we can then set the attribute. So this is the data that we've got from our design. As I said, not everything's going across to ADAC. This is information. So we go F8 on our design string for our footpath. It's got all the attributes that it requires to be mapped. Again, we run our setup for design. Use our favorites. And then process to ADAC. So we now look at the assets that are ready for ADAC. And as a pathway, for instance, here's the information that was gleaned from our MTF file. So those attributes, or any of those attributes, are, again, as we showed, available to go to Google Earth and KML, but also to our IFC bin. Information about the structures. Not only have the ADAC attributes, but also any string attributes from your drainage network.
Thanks, Peter. So as you can see there, those attributes, we are showing them in the BIM system Celebri, which is a good BIM collaboration tool. And the beauty about the ADAC is, to say, once you've done it for one council, everyone else who uses ADAC is the same. We can read data and use all the labelling routines then straight away from anyone else. The thing we've added in there, although the ADAC XML says how to actually, where the data is structured, It doesn't then say about workflow. So you might have a surveyor who picks up some information, but he doesn't want to put values in there that he's putting the wrong thing. He has to be able to say, oh, I haven't got it yet. And similarly, it can go down the chain. And we've done things to allow for that, just like we showed there, that you can set it up for each council, so you can say which assets they want, which values and things they're not. That's the extra important stuff we've done, as well as all the labelling things you can do with ADAC. Right, with plotting, we'll have some look at cutting. With the sections and long section plots, you can do labelling of cuts. You could do X and Y as before, but now we've got X and Y and Y and X. You also can do external diameters and widths for pipes. So the drainage and sewer pipes, they can have a wall thicknesses, and so you can actually label those values. The ordinary ones you get coming out the values are the internal things. With a drainage long section, you can now just pick one string from a model. You have to give the model, and it can just draw it on its own. It'll show where all the other pipes and things comes into that string, but you don't have to plot up all the things in the network. You can just do one string. With the long sections, you can now do grids on long section plots, and then you can label. You'll say how often you want them, ups and downs, left, right labeling. So it's all up to you what you want there. And there's a new thing there for what we call height calculation method. And it's in the graph area, and I'll show what that is shortly. The choices you get are full height or, full height primary string only, fixed height primary string only, and fixed height all. Now I'll just explain them all to you, because once you know they're pretty straightforward. Fixed height all is our standard one we do now. The all just means we use your long section, your primary string, all the tins and all things in the offsets model to work out how big the area has to be to display all of them. So that's what we do now. A new one there is fixed full height primary string only. That only uses the primary string to determine what the height of the plot's going to be. And I'll show you what that's going to come out like. With the fixed height one, we actually say, right, this thing has to fit into this fixed height. So obviously the string mightn't fit in there, and you've got the choice of using all or the primary string. If it doesn't fit, we then put in datum breaks. So we'll make sure it keeps fitting into that size. So for full height, primary string only, so this is the normal sort of plot, except what's happened here, the window it calculates is only big enough for the primary string. So where the tin duct's below it, it'll get chopped out. So we can get around that though, and this is where the extra space comes in. Here I set an extra space at the bottom so we can see a little bit more. So this is a good case where you've got a lot of things in your offsets model that are way off and you don't want to see them. You can say, look, I just want to use my primary string plus a little bit more top and bottom. Now the fixed height primary string, in this case you've got to say a bit more information, and if we have a look at our graph area, this is where you've got the choices, and you now have to give a height, a fixed graph height, and it can be either world units or in millimetres. And also down here is where we had our extra space bottom I was using. So in this case I'm setting this value to 1 unit, and what's happening here, it's primary string, so it's only using that to fit it in, and you'll see down the end there that it actually has got a datum break. It was going to run outside that area, so it just put in a datum break. And we've got the datum label there, and there'll be another one further on for the rest of the plot. I'm only seeing part of it. Now again, what we can do is the same sort of thing, but add a little bit more to the extra bottom. So that's actually going to mean we're going to have to chop out that primary string earlier, so the datum break will come in earlier. As far as how that datum is being labelled in this case, you've got lots of choices there. I'm using the centre, so it's putting it in the centre of the datum, the break area. You can put to the left or the right. There's all sorts of things to control it. With that, you can also have grids, as well as the extra space, and you can see there this grid's been labelled on the left and the right, and you just put it the right way so they don't overwrite each other. And of course the grids won't line up once you get a datum break, but it all can be done. With cross-section plotting, you can have grids on cross-section plots. You can use only the primary string for the graph height area, the same idea as for the long section, and then the extra space in that top and bottom can give you a little bit more than just the primary string being shown. We can do just one cross-section per plot. There are a few customers who are after that. But the other thing we've done here quite a bit is to do with uprights. Now normally, in a cross-section, we put uprights wherever there's a point, a vertex on the primary string. So now we're giving you a choice that you can actually turn that on or off. Now, if you turn it off, of course, you're going to have no uprights, you'd think. But we now have, you can have a user-defined interval as well. So you can say, look, I want one every 5 metres offset. And you can have, these are intermingled. You can have one or the other or both. So in this case, I've actually done a cross-section where I've got the uprights, the vertices, plus also some regular intervals. And this one, I've just got the regular interval and not at the primary string points. We also can have the start and end of the primary string, because if you're doing user-defined intervals, you just mightn't have the start and end mightn't be in that range. We also can have the start and end of the extension area. And we also can have in the left and right extension areas, you can actually have your uprights now in that area. So, for example, here, you can see we've got uprights outside this area. There's no design value there because there is no design. And then in that case, we've got also the vertex heights turned on. And all the other things you've got for controlling the vertex height still apply. And here's one where we've just got regular intervals only. And also going out in your left and right extension areas. Obviously, this sort of regular interval is great when you've got natural section cross-sections which could have hundreds of points in it, so it makes it very hard, and you don't want to label them all. Right, the next thing we're going to look at is ePlan. Now, this is something that's coming in Australia-wide. New Zealand have been doing it since about 2005. It's for putting in deposited plans. So for cadastral surveyors, this is the way. They're no longer going to be giving plots anymore. They're going to start giving them basically like BIM-type data that goes straight into the system. When we go to the one this morning, there was lots of New Zealanders, so they were typing us all sorts of comments like, oh, Australians, 10 years behind and stuff. But we are learning, we are getting there. It's currently being introduced in Victoria, New South Wales and Queensland, and the other states are watching how it's going, and as it gets momentum here, they'll follow on as well. It's not probably going as quickly as these jurisdictions were hoping, but it is going to get there, just the same as it did in New Zealand. So, yeah, we're a little bit slower here, but we're working with each of these jurisdictions to make sure we can produce ePlans as they require them, straight from 12D model. And we've done, in fact, most of the plans done in Queensland have come out of 12D model, and we've also done a number of New South Wales. And we're working strongly with Victorian Department to get everything right for there. So over the next couple of years you'll see it, and it also will then go, for people who got in from Western Australia, it will go right around Australia over the next 5 years or so. Because it may be that some of the things we're doing in Australia then will find its way into the New Zealand product.
12D's ePlan network is found under the Survey, Network, ePlan. Then we have the 3 jurisdictions currently available for ePlan networks. There's also an option here to import the Queensland framework, which creates superstrings that you can manipulate as usual inside 12D. So if I select Queensland, then I can fill out the information relating to this network, the model name, description, datum information, things of that nature. You also get a helpful description down the bottom, which tells you what each field needs. You also get the option to import an existing framework file and scale and rotate. I've created one here already. To edit an existing one, the strings editor, pick and accept the network, and you get this helpful toolbar here, small, lightweight, and doesn't take up much room on the screen. If you want to see these options displayed as a menu, you can right mouse button, and there are all the options displayed in text. In the middle of the tree we have the network information, which shows you all the point information, segments and parcels. Some of the settings you can have on the network under display settings is dynamic pan. You can have that turned on or off so that when you select onto a point, it will auto pan to the point. There's also this info, which will give you the information about the point that you're closest to with your mouse, or segment information as well. So nice to keep that open and use it whenever you need. There's point information, so you can add points, import points, edit CG point, edit monument points, and also delete points. Similarly with the observations, there's add, import, and edit. There's import boundaries and create boundaries, and there's parcel information, monument information, the export option just there. So if we have a look at maybe just importing a couple of things, under the observations here, I can import, and I can choose to bring in my pins here. So this gives you a tolerance area. I can set that to 0.2 and import point information. Yes, I want to bring in the points, and you can fill out all the state and information about how they were surveyed, whatnot. I'm just going to choose it and then just hit import. So it will import the pins in here somewhere, just off to the side here. Under the network, under the parcels, here's the parcels that I'm creating, and you can see that I've set them to created, and here's my other one, and here's the one I'm extinguishing in here somewhere. So that auto pan, as you can see, is nice and easy. When you edit the CG points in here, you can see that when I pick onto a point, they pan around, and it's easy to see what point you're editing. So these are some great new features with the ePlan. And when it comes time to export, it's just export XML. And you give it a file name, got one here, right, and that creates your XML file ready for validation on the portal supplied to you. Depending on what state you're in, it differs. And you also get some great options here under the settings to transform points, so you can scale and rotate and translate the network if you need to get it onto datum. And once you're finished, you can also extract the points out of this into points that you can upload to your total station. So under the export, there's extract points, which will create a model of points, and so it just creates those points on top of all of the network data there, so that you can use them, like I say, for uploading to the total station.
Right, now moving on to some other things that we find useful with the volumes. For a lot of these with end area, instead of using the whole string, you can now restrict it, so you can have a start and end change. For the section to heights, section to sections, tin to sections, they've all been done. Also with the tin to tin by height range, before I think again it just had regular interval, you couldn't actually use a string. Now you can actually use a string and an interval to work out those calculations. With the tri-mesh, there's volumes and area for individual tri-meshes. The other one which Peter showed, I think, yesterday, you can actually say, I've got a string, I want to work down, just like your normal, say, apply mini, I get the volumes down the string between chainages, and it works that out for the tri-meshes. It doesn't have to cut the tri-meshes like we did with a similar option that broke it up. It just works it out for you without cutting them. With chains, look, we've got a lot of extra things here, and I'll mainly get Peter to show them to you. There's extra things like execution, a whole lot of stuff in conditionals, things for views. So basically, we'll just get Pete to show. It's easier than trying to explain them.
Just on utility chains, we'll have a brief look at some of those options. Going under the execution to run a plot sheet, under elements, calc extents model, and profile a string on a section view. Under views, we've got the option to create views, and inside that creation we can also then run favourites on the view. We can regen the section view, we can tile views. Under the other options, you can play a WAV file. And under conditionals, you can check whether the model is shared in or tin or not. You can also check whether super alignment solved, and also whether applying many is valid. So you may have an option here where you've want to be able to do a process, reporting files, doing all sorts of things, but you don't want to do it necessarily. Apply many does solve, and at least it's a warning. You can go and find out what the problem may be. Under here, we've got a one for a section view. Again, we're going to create a long section. So we're creating a type of view with this new addition of the favorites file. That's again under the section view. If we go into favorites, This has been saved with all settings in relation to the section view, annotations and so forth. So as we create the view in the chain, we're going to be able to settle that information. We're also going to be able to profile the screen. So we've selected our alignment screen. We're going to maximise the view. We're going to fit the view and then re-get the section view just in case at the end. So run that chain. Then you can create the section view for me.
Right, thanks, Pete. Now, one thing I just skipped over very quickly, you can actually also now compile chains. What that means is you run a process on it, and then once the people get it, they can't actually see what's in it. So it's very good once you've got your chains, you can compile them to hand them out to other people, so then they don't go and fiddle with your chain. Macro calls, we've added in heaps of macro calls, so we're more for the macro call people. So they're just there in all the areas with trimeshes and doing things with a super pipeline, lots of things for views. Now, coming to XML reports, we're running a little bit later. I think we'll be about 4 or 5 minutes over, so I'll just get everyone to shorten things up a little bit, so bear with us. With XML reports, we have been working through to try and produce lots of XML reports for people. So the main idea is then, we've got the XSLTs there, and people can vary them and customize the reports themselves, since the XML is now fairly well defined. But we've always wanted, though, the problem was we wanted the existing reports to be exactly as they are, because a lot of people have written programs to take that data, and if we change it, they'll all stop working. So what we've actually come up with, a way, so there's now a report field in there, so everywhere we do one of these, there's a report type, and one of the things on there is legacy. And what that means is, if you pick legacy, it produces exactly the same standard text file as before. And then you have your other options. So we normally provide an HTML one, and then you can have your own customized ones as well. The biggest thing, though, even though there are extra fields on there, all your SLXs and chains will still work exactly as before. So you can, these XML ones can come in and nothing will get upset. You don't have to change any of those things. So for an example here, there was a legacy report, but just running it again with the XML, it comes out like that. And so you can then vary the one on the right however you like and produce PDFs or whatever you want. The places we've got new XML reports, we've gone through most or all of the end area volumes. They've all got XML reports. The exact volumes, the same thing. We've tried to go do all of those. The trimeshes, they're new reports, and all our new reports are in XML straight away. And with whatever else we can find, we've done it. So basically, if there are others, come and let us know. I think the volumes and things like that are the major ones to start off with. The apply mini will have an XML report in by the apply MTF, sorry, when it comes out. Right, now just looking quickly at a couple of things in the drainage. We'll let Rob do a lot more of this at the conference, since you need to have drainage people talking to drainage people. But some simple things we've done that we can talk about is that now you can have additional and custom pipe shapes. So you can make quite strange pipes and use them inside the analysis. We support the EPA SWMM Hydrology. There's a lot of people, especially in New Zealand, who use the EPA SWMM Hydrology method. Where you've got a KU drop, we can calculate it. We show it on the HDL on manholes and things. And the Basin infiltration types, you can find those in the hydro file. Now, when it comes to Drainage 2D, this is becoming more and more popular, and a little good announcement towards the end on Drainage 2D. With road flow, before we just wrote out the mid-MIF files, but we also now can write out shape files. They're the ones that there's Esri's format, which is a published format, luckily, and a lot of other people use it. So you can now choose to write out shape files. With the road flow, before we really only could have one depth when you had a rectangle which you choose, so you could only have water going out and had one height or load shown. It now can have multiple ones, so it makes it much more accurate for doing that sort of work. And another very important thing, which I'll get Rob to demonstrate, is that when you do a Qflow run, often you're wondering why water does certain things, but we now can actually check what Qflow actually uses and give you some insights about why you get the results you do.
When doing basic or advanced Drainage 2D two-flow modeling, it's essential to look at check files to ensure that you know what two-flow sees when it does its modeling. We've been looking at many check files in the past, and these are all the standard check files that you tend to look at. With the new release, we've got an additional check file that makes it very clear to see the grid that TwoFlow uses. So what I'm going to do is, we're taking a look here at our data train model. Over here, we've got our check file that's referred to as the Z-point check file. In this check file, you get the elevation of the cell center. So you can see this flat zone here. This would be the center of the cell. And then every cell has the side elevations as well. So in this case, you can see it slopes down to the side elevation, and on this side, it slopes up to the other side elevation. So you can see exactly where the water would go, or float away from this cell here. Now, when we're taking a look at the results, if I added on my road flow results onto this view here, you can see I have my initial dam up here, which is actually what you see across here. And you can see that some water will make its way down and around these regions here. But it's often difficult to see with the original tin just why exactly is it that TwoFlow feels that water can go through this section here. And of course, it depends where it got its elevations from the sides. We come across to the Z check file and add on that same road flow results. What you can see is because you're seeing exactly the cell sides and the cell centers that TwoFlow is using in its modeling, it becomes a lot more evident that you can see the flow patterns and the very small breakaway sections where TwoFlow has a small connection allowing the water to get down the sides. So these Z points, how do we get them? We take a look back at our drainage 2D. The first one is if we run by the road flow, whenever we read results, we always get the check files back in, and this additional tick box here is what gets that grid tin for the Z points. If we are doing the advanced modeling and we're using the TwoFlow TCF editor, we go and load up that TCF editor. When we read the results from there, it's got a separate tick box once again for the Z points, and then selecting the read check files is the one that reads those in order to create this view that we see here with a very detailed description of the TwoFlow grid.
Thanks, Rob. I must admit, listening to you these 3 or 4 times now, I really understand what it's all about. That's fantastic. I really do appreciate it now. We also can look at a lot of the TwoFlow results in different ways, because again, to be able to look at the real data and things really does make it much easier to debug. And in the TwoFlow now, with the TwoFlow string editor, there are additional string types, such as the Z-shaped ones which we use in the dam breaks. As far as the results as well, we automatically create 4 grids now from the results. So you don't have to do anything, we just do it automatically. There's a depth one, the velocity, a hazard, and a water level with depth colouring, ready to do visualization. I'll just play you a quick visualization here to give you an idea of what that all means and how fantastic it is. So basically, we'll use it for a dam break exercise. So here we've got the dam, and you can see with the colouring there, that's telling you how deep the water is. So it's building up behind the dam. It breaks and spills over, and you can see it getting deeper and deeper. Very hard to work out that information any other way, and easy and beautiful to show it like that in 3D. This is actually a timeline in 12D, and we've sped up the time, so that, as you can see, ticking over there. And I say, with that visualization, and that just comes automatically with it, that you're able to produce those files. Well, we're now going to have a look at the last part of Synergy, and Richard said he'll just cut this back a bit, so it'll be under 5 minutes. I think we're going to probably end about 5 minutes late, so certainly hold on to the very end for some big announcements. So over to you, Richard.
Hi. My name is Richard Stollier, and I'm the Technical Lead for 12D Synergy. Welcome to Part 3 in the What's New for 12D Synergy in version 3. In this session, we'll be talking about file replication servers. In a regional or global work-sharing environment, there can be a large amount of traffic running between all your offices. File replication servers help you significantly reduce the amount of traffic between those offices or sites by synchronizing and caching files in the background. This means that when people come in for work, they can be sure that the files that they need are sitting there waiting for them, and they don't have to wait for large transfer times across the internet. I'd like to take this opportunity to take a quick look at the 12D Synergy landscape to give you a better picture of how the file replication service fit into the picture. Essentially, regardless of where you are, whether you're inside the office or out, you're typically connecting to one centralized 12D Synergy server. And this is essentially the model in version 2. You can already use 12D Synergy to work share in a distributed environment without using the FRS. So if you have offices in Brisbane and Sydney and Melbourne, your users can still access data from any of those offices using 12D Synergy. And our intelligent data transfer tools help reduce the bandwidth significantly by only delivering the changes that people need. However, if there are multiple people in the same office accessing the same data, then the first time they do this, they're all going to be delivered the same change. So if you've got 5 people in your Brisbane office opening the same 12D model project, or rather the same version of the same 12D model project, they're all going to get a copy of the changes the first time. And these changes could be large. So there are still some efficiencies that 12D Synergy can give you when you use the FRS. So the 12D Synergy landscape with file replication service is a little bit different. Everybody still connects to the centralized 12D Synergy server for all their metadata or informational needs to list which files are available, which 12D model projects are available, who has made what changes, to search for information and all that sort of stuff. But this doesn't take up much bandwidth. It's actually very quick to access that sort of information. All that heavy load is really in the file transfer. So with a file replication server, you put a file replication server at each of your remote offices, and instead, when you request a file, the users get the files from there instead. And overnight, or at various scheduled intervals, the synchronization occurs to transfer files between your 12D Synergy server and all your remote file replication servers. And you can set up all sorts of rules about how and when this occurs and the different types of files. For example, only transfer ECWs overnight, but maybe transfer 12D model project changes every hour. This makes sure that your users can really quickly access the data they need and allow that transfer to happen in the background, rather than having to sit around and wait for it to be available. The FRS is really ideal for sites with popular data sets that are being used by many users at different sites. So rather than making them all wait for it to be downloaded the first time they open it, you can push it out to the local network to make it much faster. It's great for data-heavy environments with more than one site. So if you've got really large ECWs and you don't want people to pull those down all the time, you can have those pre-populated onto the remote office FRS. Alternatively, it's very good for environments with sites that have significantly reduced bandwidth. So if you've got a site office that you need to have access to 12D Synergy, it's a temporary office, it may not have the best connection to the internet or your network, so the FRS can help you out by transferring the data when people are in their downtime or away from the office. So we've got an example here of a multi-office solution run the FRS. So the main server sits in Sydney, and then you have FRS nodes at each of these. Now, these little lines here actually explain the way the data is being transferred. So, and this is important to note, not every connection is the same. Some offices have faster connections, some have slower connections. So the FRS is set up to allow various types of network topologies so that people can basically route the data down the best paths. So for example, Geelong may have not a great connection through to Sydney, they've got a better connection through to Melbourne. So you can force the files to take that transfer path so that you can take advantage of your network topologies. Thank you very much for your time in watching the What's New in 12D Synergy. We hope that this has been informative and that you're all excited about some of these new features. Please do contact us if you have any questions. Thank you very much.
Thanks, Richard. We're actually using this ourselves for various sites here and overseas. It certainly does make things fantastic. Right, we're into the last little section now. It only takes about 4 minutes. With tunnels and structures, there's actually 2 definition styles now. There's a traditional one you had in version 11, but you also can do it from your version 12 from your MTF and snippets. So the designers can do very fancy tunnel things. There's new options to create snippets from a profile, which Peter demonstrated, and you also can just take a plan view of a section for a tunnel and use it to generate the tunnel. You also can say, if you've got a tunnel definition, you can take a string, pick a chainage, and say you want to export the sections through it to a superstring. And that might be perpendicular or a normal to the centre line. With 12D field, just a couple of points here. With set out, there's a whole lot of extra attributes you can now do. You can reset the backsite using your check shot panel. So if it's a bit out, you can say use the new one. With 12D field set out, wherever you had tins, you can now utilize tri-meshes. And this is a lot of the options. Now we'll be using tri-meshes as well as tins for things. There's new menus there for user values, and you can set that file up, and basically then when you do shots, it will display that information, so it's user definable. With measurement rounds, you've now got on-screen point selection, and also when you put in the rounds field name, it auto-loads the other names you require. There's a scale factor in the measure rounds, and you can set the number of rounds to 6 if you wish, which is required for the New South Wales RMS, the Roads Authority here. With pickup, you've got lots of other things happening, but also these bigger keys for incrementing and decrementing. In fact, also the 12D field set out, you can use its station set out within 12D field pickup, so they're coming together much more. And there's a new fast calculation, so out there it's much faster in the field to actually if you've got a slow computer. On-screen menus, again, they're coming more and more available, so you can define them and make big buttons and things to look at, just to make it easier on those sorts of tablets. Now, as far as with the 12D field tunnel, you can now use a PRF file or a face pickup, and you can limit and pick that directly out there, the field. With GPS, any GPS unit that has a standard NMEA string, NEMA string, we actually can support them, and most of them do, so we support most of those units. But when it comes to the robotic instruments, version 9 we had the Leica robotics only, then for 10 we added in the TopCon robotics and compatible sockias. In 10 we also did the lighter robotic model upgrades as they came out. For 11 we did the Scitech SBS series robotics, that's a division of Trimble, and also the Leica MS50 scan station robotics. What we've done for 12, we're now supporting the new MS60 Leica scans, and there's a whole lot of tunnel face scan options, which we're using that on a site at the moment, which we've shown at the conference, so it's going to be a great talk to come along and see how that's just being used. And you can define the scan extents by chainage, element, and a PRS file to restrict exactly what you're wanting to pick up. You can have predefined or in-field measurement polygon scanning. So out there in field you can pick points and say, look, I only want it inside this region. Don't go crazy and do everything with your scanner. We can convert and download the attributed point cloud straight into a 12D point cloud. And another few thing we have, which is a great announcement for people, is we now have a new Trimble connection. So if you've got a Trimble S-series instrument, we can actually now hook it up to 12D field pickup and 12D field set out. The S6 and the S8 we've been testing, and they're going quite well, and we'll be working on the S5 and S7s, so they're all coming along. You can use cable, direct Bluetooth or serial radio, and any tablet, so it's not restricted to the Trimble tablets, any tablet at all with Windows 7 or above. And we have the full instrument functionality, it's all measured and used from the tablet. So you should, for most of you, be able to go from one, look the same on whichever instrument you hook up, depending on what capabilities those things have. So there's where we've got to for some of the things in 12, but if you sit there and thinking and dreaming, you think, wouldn't it be nice to have 3 days with Peter Tayton so you could go through all those MTF and snippet commands with him? And wouldn't it be nice if you're on maintenance, if you had access to a 100,000 point version of RoadFlow at no additional cost, so you could do a lot of that TUFO things have been showing. And what about, could models, tins and functions be organised a little bit like in trees, like in Explorer, so it's much easier, so you don't get a huge list of these things. And what about, would it be nice if you could check on duplicate names and other things amongst your super alignments and MTFs? It'd be very nice if you could see the dependencies that you have for a super alignment. So what does it depend on and what depends on it? And it'd even be nicer if you actually see that as a graphical relationship of all the dependencies. And it'd be great to have a multi-page plot sheet. So each sheet on it could have a mixture of plans, selection of cross sections, and any parts of long sections on it. And it'd be nice that you could see a quick draw, say, of what you're doing when you're placing the frames on that sheet. What do you think? It'd be great if you could perform clash detection on tray meshes. And if you had, another dream is to have a 12D viewer, so anyone, anywhere then could look at the model in a 12D model project. So come along to the 12D conference in July and just see how many of those wishes and dreams and many more do come true. The 12D Model 12. Thank you very much for your time.
Thanks, Lee. If you enjoyed today's webinar, keep an eye on our website for upcoming webinars in our industry solutions and training series. We'll keep updating it with many more topics in coming weeks and also keep you posted through email and social media. If you need to contact us in the meantime, our details will be on the screen shortly. That concludes our presentation for today. Thank you for attending.